The James Webb Telescope has once again proven itself to be one of humanity's most extraordinary tools for unlocking the deepest secrets of the cosmos. Equipped with state-of-the-art infrared technology that dramatically surpasses anything that came before it, the James Webb Space Telescope has now made one of the most exciting discoveries in recent history: a highly promising, potentially habitable super-Earth, located just 40 light-years away in the fascinating TRAPPIST-1 star system. This newly identified super-Earth, a rocky world significantly larger than Earth, yet smaller than gas giants like Neptune, orbits within the so-called Goldilocks zone of its star, where temperatures are just right to allow for the presence of liquid water. This region could be key to life as we know it. It's a staggering discovery, one that stirs the imagination and prompts a thrilling question: could this distant planet actually host life? And if so, what kind of life might have evolved under such alien conditions? Super-Earths like this one are unique and intriguing. They are larger than our home planet, yet still rocky and solid, occupying a special place in the spectrum of planetary types. Their increased mass typically leads to higher surface gravity and thicker, more protective atmospheres, which may help shield potential life forms from harmful space radiation. These conditions could support environments not just survivable, but even ideal for forms of life both familiar and completely unknown. Using its unparalleled spectroscopic instruments, the James Webb Telescope was able to detect key atmospheric components, water vapor, methane, and traces of oxygen, all essential markers that, on Earth, are closely associated with life. The presence of these molecules suggests that this super-Earth may be one of the most promising candidates for habitability we've ever encountered. The TRAPPIST-1 system itself has long fascinated astronomers. It features 7 rocky planets tightly orbiting a cool red dwarf star, 3 of which lie in the system's habitable zone. And now, this newly identified super-Earth has taken center stage, becoming the crown jewel of this remarkable planetary family. TRAPPIST-1 is an ultra-cool dwarf star, far smaller and dimmer than our Sun, but its lower energy output offers a surprising advantage: a more stable radiation environment, reducing the frequency of destructive solar flares and atmospheric stripping. However, the planet's close proximity to its star likely causes tidal locking, where one hemisphere is forever bathed in sunlight, while the opposite side lies in eternal, frozen darkness. This condition, while extreme, may not be a death sentence for habitability. Scientists believe that a thick, dense atmosphere might redistribute heat, creating a livable band along the planet's terminator, the narrow region where day meets night, possibly offering temperate conditions suitable for sustaining life. This twilight zone could be the most stable, life-supporting region of the planet, a narrow ribbon of hope in an otherwise harsh world. What makes this discovery truly electrifying is the detection of potential biosignatures, chemical signals in the atmosphere that are often linked to biological activity. The observed ratios of methane, oxygen, and carbon dioxide are difficult to explain through geological processes alone, and could point to the presence of living organisms influencing the atmosphere. Although alternative, non-biological explanations exist, the idea that these signals could be evidence of alien biology has reignited public excitement and scientific curiosity around the globe. Even more compelling is the presence of water vapor, often referred to as the elixir of life. Water is not just a requirement for life as we understand it, it is the medium in which life on Earth began and evolved. The detection of water vapor in this planet's atmosphere raises a profound possibility: that liquid water might exist on its surface, or in vast underground oceans hidden beneath a protective crust. If surface temperatures prove too extreme for life, microbial organisms could still thrive below ground, much like Earth's extremophiles, life forms that survive in boiling hydrothermal vents, frozen ice caves, or acidic lakes. Yet, tidal locking introduces severe climate extremes. With one hemisphere scorched by constant daylight and the other locked in icy darkness, how could life endure? Once again, the planet's dense atmosphere may provide an answer, acting like a planetary thermostat, circulating heat and moderating temperatures globally. The possibility of life evolving in this perpetual tug-of-war between light and shadow opens up visions of ecosystems vastly different from anything on Earth, perhaps with organisms that have adapted to constant dimness, or evolved photosynthesis under alien suns. None of these insights would be possible without the revolutionary James Webb Space Telescope. Its ability to detect faint, infrared signatures from light years away has changed the way we understand not only distant planets, but the very nature of what it means for a world to be alive. By analyzing these distant atmospheres through infrared spectroscopy, Webb has uncovered a level of detail once thought impossible. But this is only the beginning. Future missions including more powerful telescopes and space-based observatories will build upon Webb's groundbreaking work, and continue to study this mysterious super-Earth with greater precision. At the same time, visionary projects like the Breakthrough Starshot initiative are planning to send microscopic spacecraft powered by light sails to nearby star systems, possibly reaching TRAPPIST-1 within just a few decades. Such missions could give us our first direct look at an alien world up close. And as the search for life intensifies, so too does a critical question. What should humanity do if we detect intelligent life? Some believe we should reach out, make contact, ask questions, share knowledge. Others urge caution, warning that we have no idea what kind of civilization we might be dealing with. Physicist Michio Kaku has voiced such concerns, noting that revealing our presence could expose us to beings far more powerful, who may not have our best interests in mind. The debate is growing louder, as we inch ever closer to answering one of the oldest questions ever asked. Are we alone in the universe? This discovery is more than just a headline, it's a milestone in human history, and a spark that may ignite our next great leap forward. A reminder that we are part of a vast, dynamic universe filled with wonders, mysteries, and possibilities far beyond our current understanding. The search for extraterrestrial life is no longer science fiction. It's real, it's happening, and it's unfolding right now. If this discovery has sparked your curiosity, if it's inspired you to look up at the stars and wonder what lies beyond, then we invite you to join us on this exciting journey. Like this video, subscribe to our channel, and activate the notification bell so you don't miss the latest news from the James Webb Space Telescope and beyond. Thank you so much for watching. And as always, we'll see you in the next